Hi guys, Jet86 here, going to take you through a demonstration of how to download, install and run the Golem Alpha on Windows 10. We'll be using the latest version of the Golem Alpha, which is currently 0.11.0, and I have a brand new Windows 10 system here. I've applied all the current updates that are available to Windows 10 but haven't installed anything else. So you should be able to follow along and install it yourself if you have a Windows 10 system. So to start with, we'll open up our browser, in this case Edge, which comes pre-installed, and we'll go to the Golem homepage, which is golem.network. And we want to go to download and test. Scroll down, it has instructions for Mac OS and Ubuntu that you can follow along as well, or I am making videos for those OSs as well, and the links for them will be in the description below this video. But for Windows, we want to click download and execute the installer from here. Click on here, and we're going to go ahead and save the installer. Now this will take a little bit of time to download. It is a fairly large installer for Windows because it has to download all the required dependencies as well as the Golem app itself. So I'm going to go ahead and speed up this download on the video now so that you don't have to wait around like I do. Okay, so now that the installer has finished downloading, we can go ahead and run it. And we'll close the browser for now while we do that. Now this installer contains with it all the necessary dependencies to install and run Golem. The only thing that I will say is that your computer needs to have VTX or AMD-V, depending on what type of computer you have, enabled in BIOS for it to run. If you don't have that enabled, or if your computer doesn't support it, you will get an error when you try to install or run Golem. So we'll go ahead and start the installation of Golem now. So it's going ahead and installing Docker. Docker is a way of creating virtual machines that can run easily on Windows, Mac and Linux computers, and it's actually how Golem runs. So Golem creates a Docker VM to run each computation on your computer. So that's what keeps the computations that Golem is running separate and safe from your host computer. So obviously we need to install this device software. It's installing VirtualBox, which is now owned by Oracle. It's open source VirtualBox virtualization technology. And the Visual C++ redistributable from Microsoft. And now we can go ahead and install Golem itself, accept the license agreement of course, and of course you'll read through it thoroughly before installing it. And then clicking next. Now I'm going to go ahead and add it to the startup folder and the quick launch toolbar as well, but obviously those decisions are up to you as you install it. And now we install. And then we can click finish, and we need to restart because of the nature of the product that it's installed. The virtualization needs to have a full restart for it to work properly. So we're going to go ahead and restart it now. And we can go ahead and log back in. Now, because I've added the Golem app to the startup folder, I ticked that option. It should launch automatically in a second. If you didn't add that, obviously you'll just need to double click the Golem app on your desktop, or you can find it in your start menu as well. And there we are. Now, the first time you run Golem, it will take you through a couple of basic information steps. This first one is telling you that we need to forward ports 40102, 40103, and 3282. I'll go through in a minute checking whether they have been forwarded or not. The good news is that in this latest release, 0.11.0, UPnP is now enabled in Golem. If you don't know what that means, it basically means that Golem will try to get your router to automatically open those ports if your router supports UPnP and has it enabled, which a lot of routers do, but not all. So as I said, in a minute, I'll show you how to check whether the ports are open. But for now, we'll click through this information. Second step, you will want to put in a name for your node, because that's useful for troubleshooting and for tracking things online, which you'll see a bit later. So we're going to call this Golem Win 10 Demo. And it goes through a basic explanation. So we've got the network tab where you run Golem, set your allocation, and view your earnings. The tasks tab where you actually create tasks to be run on the network. And it's telling you about that little icon, the Docs button on the toolbar. It says should answer most of your questions, and you're also welcome to join our public chat. The Docs button is great. It takes you through a lot of important information, which you can look at yourself, and I'll show you in a bit as well. The public chat is really great. If you're having problems getting things working and this video and the docs don't help, jump on the chat. Which is found at chat.golem.network, and jump in the testers channel, #testers, and you can get a lot of support and help in there. So we're going to go ahead and get started. And down in the bottom left, it tells you what it's doing. So it's trying to create the Docker virtual machine. It'll also be syncing with the Ethereum network in the background. Currently, because it's an alpha, it's running on the Rinkeby testnet. If you don't know what that means, don't worry, you don't need to. In a little while, we will eventually get a wallet balance of 1000 GNT and a small amount of ETH. The important thing to note, and it's really important, is that because we're on the alpha and we're on a testnet, that's testnet GNT. So it's not the GNT that you can purchase on exchanges. It's simply given to you for helping to test the product. So there we go, the VM has been created and it's now downloading the Docker images to run Golem itself. So the Golem application runs on your computer, but then the actual computations and all of that, as I said, are done in a virtual machine which the application can connect to. So it's just downloading those images now. And this can take a bit of time to download these Docker images, so don't worry if it's taking a little while. That's perfectly normal. Okay, so because I've got Windows Firewall on, it's telling me the app is unknown, so obviously I need to allow access, otherwise it won't be able to connect. Same with Hyper-G. Hyper-G is used by Golem for the connection, so you'll need to allow access to that as well. Okay, so now as you can see, there's that 1000 GNT, which is actually testnet GNT, and we'll have a small amount of ETH, 0.03 ETH as well, which is testnet ETH. So in this current version, there's no deposit or withdrawal buttons. They will be added at some point soon in the alpha, but even then, it will still be testnet GNT and testnet ETH until Grass Golem 1.0 is released and it's switched to the mainnet, the Ethereum mainnet. Once that happens, you'll be able to deposit your real GNT and Ethereum, and you'll be able to receive real GNT and Ethereum for computing tasks for others. Now you can see it's already connected to one node. If we wait a while, that should go up to a number of nodes. But while we wait for that, I'll show you around the interface. So first thing is the resources tab. Now currently it's saying we're using none of our resources for Golem. If we click on advanced, that's not quite true, so I'm not sure why it's saying that, but if we click stop Golem, and this is a point that confuses a lot of people, you won't be able to edit. I'll just make this a bit bigger so you can see it a bit easier. You won't be able to edit these while Golem is running, and that confuses a lot of people. You need to stop Golem. Once it's stopped, you'll actually be able to either drag this slider to adjust your resources or set a specific amount. Now another thing that confuses some people is the amount of CPU and the RAM and the disk that you can set. There is actually limits to what you can set. So this machine has 4 CPUs or 4 cores, but the maximum that Golem will let me set is 3. Now that's so that the computer itself still has a core to work with to run the Golem app, and to run other things, the operating system itself and so on. So the maximums are, you can use a maximum of 1 core less than your machine has installed and a maximum of 75% of your system memory. I'm going to leave it at 2 cores, and the RAM and the disk looks fine, so I'm going to start Golem again now that I've set those resource settings to what I want. And you can create different presets, so you could have a preset for while you're working and a preset for while you're away from the computer, so that it allocates more when you're not working or not using your computer. You'll see now that I've started Golem again, we're back to no nodes connected because it obviously needs to find them again after resetting those settings. Now that we're back in resources, it's showing that I've allocated about 70% of my resources to be used by Golem. The History tab is where you will see payments that have come in for work your computer has done. So when you're running Golem, it's running as a provider, and requesters can send tasks to the network, and if your node gets selected as a provider to compute the subtask, then you'll get paid in GMT, and that will show up under this History tab. Up the top, we have the Tasks tab. This is where we can create new tasks, which I'll show you in a little bit how to do, and we'll go through a basic task. You can see Golem is ready, so it's all ready for us to add a task to be computed by the network if we want. Or we can click this plus button to create a new task directly, so we can do that from anywhere we want. We don't have to go into the Tasks tab. The Settings is where we can change our node name. So if you've put in your actual name and you've decided you don't want that to be shared across the network, you can edit it here. Or if you forgot to set it in that initial setup, you can change it here as well. You can go through and calculate the performance. For the alpha, probably not really necessary to do that. You can do that if you wish, but not necessary at this point. The price settings, so as a provider, what is the minimum price you will accept work for? So as long as the requester is happy to pay at least 0.5 GMT per hour, your node has a chance of being allocated tasks. And conversely, the requester maximum, so if you're submitting a task, what is the maximum GMT per hour you're willing to pay? Network trust, no point adjusting this at the moment, but basically you can set a minimum and maximum amount of trust for how trustworthy a node you want to accept work from as a provider and as a requester. So it's not just a price match, but it's a trust match as well. But I'd just leave these settings as is for now. And the default file location for the outputs of your renders, of your computations, I should say. And the final thing up here we have is the docs link. So if we click that, we'll open our browser, and it will take us to docs.golem.network. And this has, as I said, a lot of information and helpful troubleshooting. So if you get stuck, if things aren't going how they are in this video, click on docs, click on troubleshooting, and it has a bunch of different steps you can take to try and resolve common issues. Otherwise, as I said, jump on chat.golem.network and sign up for that, and jump into the testers channel, and you can get support directly as well. So now you can see we're connected to 2 nodes. What I'll show you is testing whether the ports have been opened via UPnP, as I mentioned earlier. So if we open a browser again, you just need to go to canuseeme.org. And the ports we want to check are 3282, okay, so the fact that it's come up with that red error message indicates that my router isn't supporting the UPnP, automatic configuration of port forwarding from Golem, so I need to manually forward it. So I'm going to jump into my router and show you how that's done. So this is my router here. Yours will probably be different, but still very similar. So what you're looking for is an option called NAT, or port forwarding, or possibly PAT. And in my case it's under Advanced Setup, NAT, and we've got this Virtual Servers Setup, which is the port forwarding option. So we need to add new port forwarding. Often they have a list of standard services that you can set up, but it almost certainly won't have Golem, so I need to create a custom service. Now this will differ from router to router in terms of what it looks like and exactly how you go about it, but this is the general process. So I'm going to go ahead and call it Golem. You don't need to worry about LAN loopback, and you need to know the IP address of the computer that's going to be running Golem. So that's the local IP address, the LAN IP address. Once you know that, you enter that for the IP address. So in my case, 192.168.0.203 is the computer that I'm running Golem on, the Windows 10 machine. Now this is what should be the same in every router. So the external port start and end, sometimes you won't be able to input a range, sometimes you just have to put in 3 separate entries. In my case, because it supports ranges, I can just put in 2. So first of all, port 3282 and 3282 for the external port start and end. Protocol we want to change to TCP and UDP, and the internal port start and end we leave as 3282. And then we need to add as well 40102 to 40103. And TCP and UDP again. Now if your router doesn't support ranges like this one, you'll just need to put in 40102 and 40103 as 2 separate entries. So I can go ahead and save that, and that will now show in the table. I ignore those other entries, that's just something from one of my other machines. And if we go back to the Windows 10 machine now, and we check the port again, success, green success. So that's what you want to see. That means this canuseeme.org site can access port 3282 from outside your network, which means other Golem nodes will be able to access it as well, which is what we want. So I'm fairly certain it will work, but we'll go ahead and check the other 2 ports as well. Success. And success. So now that that's properly forwarded, it should be a bit better. We've now got 3 nodes connected. Now keep in mind that we are running on the Golem testnet, so there are a limited number of nodes that are running on the network, and you actually won't connect to all the nodes at once. But once you have port forwarding set up, you should start to see a few more nodes. So it's common to see probably anywhere between 6 to 10 nodes connected. once you're fully up and running. And another great way to check that you're fully up and running is there's actually a stats page for Golem nodes, and that's at stats.golem.network. And this will list all of the nodes that are currently connected to the network. So you can see there's a decent number of them here, but basically what we want to look for is under node name, we want to see if we can find our node listed. And there it is, Golem Win 10 demo, version 0.11.0. And it'll show the first octet of your WAN IP address, but obviously for privacy reasons it doesn't show all of them. And it also shows you the node ID, and if you click on it, some details about how much I've allocated to run tasks. So this is constantly updating and providing stats for nodes connected to the network, how many tasks they've completed, whether there's any errors or timeouts, and their current balance. Now you'll notice most of them say 0. This is because it's not taking into account the 1000 testnet GNT issued automatically. So when you start submitting tasks and having them computed, the balance here will actually go negative, even though it will be positive in the graphical user interface of the application. And some stats for all of the nodes at the bottom. So the main thing is checking that 1, those ports are forwarded, and 2, that your node name appears on the list. And that's why it's important to give your node a name that you will recognize, but you may not want to actually use your actual name just for privacy reasons. So what we can do now is go ahead and submit a task to the network and have it computed. Now, at the moment, in the alpha and even in Grass, Golem is specifically catering to rendering tasks just for the alpha and the Grass releases. In subsequent releases, you'll be able to compute other types of tasks on the network, but Blender and Lux Render rendering jobs are being used as the proof of concept for Grass and for the alpha. So Blender is a great rendering application that's open source that you can download and have a play around with if you want. But if you're not interested in doing any renders locally, and you're just interested in trying out Golem, you can either download a Blender demo file from the official Blender website, or you can download one of several demo files that I created for testing out Golem. So if you go to golem.timjones.id.au, this page gives you 3 different test tasks that you can use for testing out the network. So you can have a look at them yourself, but I'd recommend for your very first task, download this Golem logo demo fast. It's a very small file, 80 kilobytes, and it should actually be able to be rendered by the network very quickly. It's just a zip file that we can download. I'm going to go ahead and save that. And I'll open the folder it's in so that I can extract the actual contents. And you can see it's just a single 500 kilobyte .blend file. Now, as I said, you can download Blender, have a play around with it, but you actually don't need to render a blended job on the network. So this is a clean Windows 10 installation that I've done, and I'll show you that the Blender file won't open, it's unrecognized, but we will still be able to render this task on the network. I'll go ahead and close the browser, and it's in here. So when we go to the plus, we can open a .blend file, or we can go to the Tasks tab and just drag that on. We'll go ahead and give it a name. We'll call it Golem Logo Demo. It's automatically detected it's a Blender file, so we can click on Next. Now it's going to come up with this checking, and it should very quickly say Test Passed. That's just checking that it's got all the required files in it, and that it is a valid task that can be computed. You can create your own presets for rendering if you constantly render tasks with the same settings. Obviously we haven't done that yet. I'm going to go ahead and just pick a nice small size for this first task, 1024 by 768. This isn't an animation, so for frame range we can just put 1. We'll put the output format as PNG, and we'll leave the output as the default, the documents folder. We don't want compositing. Now this is where it's important. You need to set both a task timeout, a subtask amount, and a subtask timeout. The task timeout is how long it takes before the whole task will fail if it hasn't come back completed. So I like to set that fairly high because I'm not in a rush, I just want it done whenever it's done. So I'm going to set that to 1 day, 6 hours and 30 minutes. You know, you can be as specific as you want or need. Subtask amount, I'd usually pick somewhere between 6 to 10, so I'm going to say 8 subtasks. That's how many subtasks it splits the task into. So with 8, we'll send it to 8 different nodes. So with 8, it will split the job into 8 different subtasks and send a different subtask to a different node to be computed. And so I like to set the subtask timeout fairly low. The reason is, if it hasn't computed that small subtask in 30 minutes and got it back to me, I want to forget about that node, move on and send the subtask to another node. Because maybe there's something not quite right with that node. So at least in the alpha for testing, I would set the task timeout fairly high, but the subtask timeout reasonably low, but not ridiculously low. And once you've done a couple of tasks, you can start playing around with the settings and see what works and what doesn't. We need to set a price, so a bid price. Now, we know the defaults for the bids was a minimum of 0.5 GMT per hour. So I'm going to set a bid of 1 GMT per hour, which is giving me an estimated maximum of 4 GMT. And that's simply 1 GMT per hour times 8 subtasks at 30 minutes. Gives me the 4 GMT as an estimated maximum. Now it may not actually cost that. We're going to go ahead and start the task. And it will come up as preparing. Now, while we're waiting for the task to be computed, we can actually click on this preview toggle, turn on the preview, and then click on the task. Now you can see that it's actually the bright green is tasks that are being computed. The red was a subtask that failed. And that darker green is actually the green of the background that's being rendered. So we're hitting some very fast nodes right now and having it rendered. There you go. That was rendered very, very quickly. So that's a great success. So now that we've done that, we should be able to go and look in my documents folder, and there we have the rendered result. Now remember, it's a blend file, but I don't have Blender on this computer at all, and we've successfully got a result there. So go ahead, download Golem, give it an install, give it a couple of goes with a few of the different test files, and if you have any problems, you can post a comment on this YouTube video, or as I said, the best thing to do is jump on chat.golem.network and people will be there to help you out.